Welcome to a new era in industrial production. Welcome to 5G-ACIA. What will factories look like in the age of the industrial Internet of Things? 5G makes the answer tangible. 5G will play a key role in delivering entirely new levels of flexibility, versatility, productivity, and efficiency. Let's look at 4 areas: logistics, factory automation, human-machine collaboration, and process automation. 5G campus networks provide the connectivity needed for new services and automation technology. They enable devices both inside and outside a factory to communicate and collaborate directly. For example, a truck can not only notify the devices inside a factory of its imminent arrival, but also conduct the handover seamlessly. Logistics processes can be adapted and optimized within milliseconds and with unprecedented precision. 5G will enable URLLC, that is to say, ultra-reliable, low-latency machine-to-machine communication. In our example, goods from the truck can automatically be picked up and transferred to a factory train. Within the factory's 5G network, new technological capabilities such as network slicing, closed loops, and edge cloud computing will pave the way for Industry 4.0. Cameras can automatically check the quality of inbound goods, and data is exchanged between multiple micro-networks. These edge clouds can monitor and manage factory equipment with remarkable speed and accuracy. If AGVs navigating the factory floor encounter obstacles, they can warn other mobile devices. Each edge cloud can reliably detect equipment malfunctions and rapidly identify ways to resolve the problem. During a repair, the edge cloud temporarily transfers production tasks to a neighboring robot cell, keeping disruptions to a minimum. "5G will also take human-machine interaction to a new level. For instance, it can give workers access to augmented reality for maintenance and troubleshooting. A remote expert can provide instructions directly via an AR headset. "5G will also open up a new era for process industries. For instance, via massive machine-type communication. During fractioning, multiple sensors measure defined parameters and send corresponding information to devices throughout the factory. This allows far greater efficiency at all times and on many levels. 5G has immense potential in process industries and beyond. It will enable seamless vertical and horizontal integration across the value chain in the automation pyramid. 5G will raise industrial production to the next level. Make the most of 5G for your business by becoming a member of 5G-ACIA. Visit us at 5G-ACIA.org for more information.
Well, hello everyone, and thanks for tuning in, and a very warm welcome to the digital program of the 5G Alliance for Connected Industries and Automation. My name is Andreas Müller. In my day job, I'm responsible for the industrial 5G activities within Bosch, but today I'm here in my capacity as the General Chair of 5G-ACIA. And as you can see, I'm not doing that alone, but I'm here today together with my colleague Afifo Seyran from Ericsson, who is the General Vice Chair of 5G-ACIA. So very warm welcome also to you, Afif.
Hello, Andreas.
Industrial 5G has gained a lot of momentum with many exciting developments in the last couple of years since the establishment of 5G-ACIA in 2018. 5G in the consumer business has become a reality, and a key question certainly is where we currently are on the industrial 5G journey. With our digital program, we would like to give you a little bit of an overview of the status quo and future perspective of 5G in the industrial domain, as well as some insights into some of the ongoing activities within 5G-ACIA. And we would like to start it with a brief fireside chat with some of the best experts that you could imagine for that purpose, namely the chairs and vice chairs of the different 5G-ACIA working groups. But before we do that, let us start with a brief overview of what the 5G Alliance for Connected Industries and Automation is actually all about. The main goal of 5G-ACIA is to provide a global forum for bringing all relevant stakeholders in the emerging industrial 5G ecosystem together. This particularly includes the ICT industry with infrastructure vendors, network operators, and chipset providers, but on the other hand, also the so-called OT industry, the operational technology industry, with industrial automation specialists, machine builders, end users, and so on. Together, we would like to jointly drive and shape industrial 5G in order to make sure that it eventually becomes a major success. And this huge success is also reflected by the impressive list of our current members, which include more than 80 leading organizations from the ICT and OT industries from around the world, as you can see from this slide here. And now Aviv will give a brief overview on the structure of 5G-ACIA, a little bit in more detail.
As Andreas mentioned earlier, I'm the General Vice Chair of the 5G-ACIA, and I work at Ericsson in Stockholm as Director of Industry Engagements and Research. Let me explain to you the 5G-ACIA governance structure. The members constitute the General Assembly, as you can see it in the bottom. The General Assembly meets on a yearly basis. It elects for 2 years the working group's chairs and vice chairs, the board, the general chair and vice chair. The GA has the final mandate to approve the overall budget, but the work is conducted in working groups. There are 5 working groups that meet mostly on a weekly basis. Each working group is responsible of a defined technical area, or areas even, not only one area, such as use cases and requirements, spectrum, architecture and technology, validation and test, and also non-technical areas such as dissemination and license. The progress and decisions are presented at the plenaries, and those plenaries are held 5 to 6 times a year. The full day-to-day operation support, such as admin, legal, IT, marketing, is provided by the 5G-ACIA office. And finally, the board is responsible of preparing the general guidelines of the 5G-ACIA work program and to provide the long-term strategy. So this was, in a nutshell, the working group structure and the governance structure of 5G-ACIA. So these are the working group chairs and vice chairs, and now let's talk to them directly. And I would like to mention, of course, here that unfortunately Chin-Chan Chen was not able to join us today.
Yeah, thank you very much, Aviv. And now it's a great pleasure to welcome all working group chairs and vice chairs, at least remotely. So hello everyone, and thanks for taking your time. And we start right away with the first question for working group 1, for Michael and Julie. And Michael, having a solid understanding of possible use cases and their associated requirements is a key prerequisite for successfully using 5G in the industrial domain. What are some of the most promising use cases that you would see for industrial 5G?
The development of 5G started with the promise of supporting vertical and especially industrial applications with ultra-low latency and high reliability. This is important for closed-loop control applications in industrial automation, with latencies below 10 milliseconds and very high reliability and availability requirements on the wireless communication. The most demanding set of use cases in industrial 5G are related to motion control with latencies down to 1 millisecond and below. With Industry 4.0, however, flexible manufacturing becomes very important, with flexible production and logistics as well as modular production cells. Imagine a flexible assembly line. Here, dependable wireless communication with URLLC capabilities, mobility, and support of time-sensitive networking is needed to support the flexibility and dynamics as well as the diverse mixture of industrial applications and machinery with diverse demanding communication flows. Besides this, industrial 5G will be also important for logistics, asset tracking, and process automation. Furthermore, new promising use cases will also emerge over the time due to the introduction of advanced ICT technologies. For example, the capability of localization and sensing, computer vision, or seamless usage of AI services upon communication systems. These will be the enablers for OT innovation.
Yeah, thanks, Michael, for sharing your very interesting insights. And I have a second question right away, this time to Xueli. So Xueli, obviously 5G-ACIA has already done a lot of work related to use cases and requirements and communicating them to THBP. So key question, of course, is are we there yet, or what still needs to be done also in working group 1 in 5G-ACIA?
Thanks, Andreas, for the question. Of course, bringing OT requirements to 3GPP, this is one of the essential work we are doing in Working Group 1. Other than this, we also try to explore how to bring this requirement from theoretical level to business relevant practice. For example, we have one ongoing work item on industrial service level specification, which aims to help OT partners to understand how to utilize these requirements to design, deploy, and operate their 5G infrastructures. Moreover, we also work on topics like industrial device requirement, topics like how to establish common understandings in between OT and the ICT terminologies. As Michael mentioned, there will be also new use cases and new requirements emerging due to the introduction of advanced ICT technologies. So we do believe we still have a lot of work to do in order to bring all these vertical thoughts, their new use cases and requirements from OT domain to 3GPP Release 18 and its beyond.
Thank you, Michael. Thank you, Shirley. Let's move on now to Working Group 2, Spectrum and Operational Model, and we will speak immediately to Ulrich Rufus. Ulrich, spectrum and operation models are crucial elements for successful 5G networks for operational industry. Can you tell us how spectrum for local deployments has evolved the last couple of years, globally, in particular in Europe, and what 5G-ACIA is doing in that regard? Maybe you can start by this aspect first.
Many thanks, Afif. Indeed, Working Group 2 has an ongoing work item on assessment and analysis of access to spectrum for 5G globally in selected countries of relevance to 5G-ACIA members. We look both into the general availability of spectrum for 5G as well as specifically into options for spectrum access for local industry use. Regarding bands, we currently see a focus on mid-band options, for example in Europe within the 3.4 to 4.2 GHz range, offering bandwidths up to the order of 100 MHz. But we also look into the high-band range, or in other words the millimeter wave bands, which provide higher bandwidths up to the order of 1 GHz, for example in the 28 GHz band in Japan. We see quite different spectrum access ruling in different jurisdictions. Typically, there are nationwide licenses issued to mobile network operators, often within competitive auctions. So mobile network operators have spectrum resources at hand to address 5G use in form of network slices on their nationwide networks or in forms of local standalone non-public networks. Within such nationwide licenses, many jurisdictions allow for spectrum leasing, which provides an indirect path to spectrum access for industry players should they want to deploy non-public networks on their own. And there are jurisdictions that offer local licenses to industry players directly for such purposes. From an operating model perspective, this does not preclude local spectrum license holders to task mobile network operators with building and operating local standalone non-public networks within the industry premises. So we see a wide range of choices on spectrum access in terms of suitable bands, in terms of licensing models, and how industrial 5G networks can be implemented and operated. With this, back to you. Thanks.
Yeah, thank you very much, Uli. And with that, we move on to Working Group 3, which is focusing on architecture and technology. And here my first question goes to Kurt Essigmann from Ericsson, who is the Working Group 3 chair. So Kurt, Working Group 3, as I just said, is focusing on architecture and technology, but it's of course a very broad field. Could you please briefly highlight some of the major outcomes of Working Group 3 so far?
So in Workgroup 3, we have two major themes we are focusing on. The first theme is very much 5G specific. Here we are analyzing and describing for a mainly non-5G expert audience topics like 5G network capabilities, such as radio propagation and performance. But we also assess deployment options for non-public networks and security solutions. We do all of that just to make sure that 5G satisfies the most stringent requirements of industrial-grade communication. And those requirements are mainly ultra reliability and low latency. But especially in industrial settings, 5G networks are never standalone solutions. They need to be integrated and they need to interact smoothly with existing and also with future wired communication networks. And here is where our second theme comes into play. In the second theme, we are analyzing and describing how 5G networks and devices interact with industrial Ethernet-based field buses, with layer 2 time-sensitive networks, how 5G can interact with OPCOA-based applications. And recently, we also analyzed how the digital twin technology could be adopted by 5G. So all of that analysis and all the findings we have had have been documented in the last few years in quite a number of white papers and technical reports.
Yeah, many thanks, Kurt. Very good to hear that there are so many things ongoing in Working Group 3. And my second question now goes to Atte Lansesalmi from Nokia, who is the vice chair of Working Group 3. Atte, to make it a bit more specific, Working Group 3 recently has kicked off a new work item focusing on industrial 5G devices. Could you maybe say a few words about what this work is all about?
Thank you, Andreas, for raising the topic. This is indeed a very interesting work item. The 5G-enabled industrial device is the place where 5G enters the factory floor and ICT and OT industries come together in a very concrete way. This is why it is important to discuss the topic together, and 5G-ACIA was established to be the forum to do just that. The objective of this work item is to analyze the needed functions and capabilities of 5G-enabled industrial devices so that chipset, module, and peripheral component vendors can develop and bring products to market that meet the identified requirements. The work item considers different use cases, including those that require URLLC and TSN capabilities that are very relevant for the industrial domain. The use cases are based on previous work done in 5G-ACIA. The target is to identify the architectural components of the 5G-enabled industrial device and the interfaces between them. The work has progressed very well. We have received good input from both sides of the community and are looking forward to publishing the results of this work as a white paper later this year.
Thank you, Ate. Thank you, Kurt. Let's move on now to Working Group 4 that focuses on disseminations and liaisons. And here we'll talk both to Sylvia and Uwe. Sylvia, welcome. Let me ask you immediately, one question, about the SDOs that we collaborate with. And I would say, although, 5G-ACIA is a major global initiative of 5G for industries, and we have seen, that it has been growing fast the last couple of years, it's still nonetheless important to collaborate and work with other SDOs and forums. Can you tell us which are the forums that 5G-ACIA has been collaborating with?
Indeed, during the last 2 years, thanks to the great effort of our members, we have established collaborative relationships with more than 10 major organizations from the globe. We became the market representative partners with 3GPP back in 2018, and we have signed MOUs with leading industry organizations from the UK, Europe, Japan, China, South Korea, India, and the USA. The most recent MOU, which are announced this week, is with OPC Foundation. We are united in fostering cooperation and synergies on OPC UA integration with 5G. It is fair to say that we have demonstrated a strong commitment to international collaboration between the ICT and OT sectors. We are connecting with them to share knowledge and learnings, but most importantly, to develop a worldwide ecosystem in support of the manufacturing and automated industry. I'm delighted that in Working Group 4, here together with my Vice Chair, we are building this global collaboration network even further through joint events, liaison activities, and international roadshows.
Thank you, Sylvia. Let's move on now to Uwe. Uwe, you have been driving the marketing plan within 5G-ACIA. Can you tell us how are you planning to improve the global footprint of 5G-ACIA?
We work together with the 5G-ACIA office as well as the working groups and chairs to improve the global footprint. And this work is twofolded. We use our global footprint and improve them by our quarterly plenary meetings to use the power of more than 80 members globally for dedicated tech days. The intention is to tackle the latest and greatest achievements, discuss them and demonstrate them. Our current plans, depending on pandemic situation for this, would be International Tech Days, aside with the plenaries, November, December, hopefully in Tokyo, Q1 2022 in US, as well as Q2 2022 in Taipei, Taiwan. The second area to improve our global reach will be the active participation at our online events with speaker slots, panel sessions and webinars. Here we collaborate with our large partner networks, as explained before. The next big thing will be the Digital Hannover Fair in April, where 5G-ACIA will be virtually present with broadcasting, panel sessions, as well as the first time 5G-ACIA endorsed testbeds. Very, very handy live demos. Followed by our mid-2022 second webinar series, where we touch the latest and greatest white papers developed by our working groups like integration of 5G TSN, digital twins, security aspects, performance testing, as well as exposure of 5G capabilities. And we will proceed along this line in 2021. So hopefully with face-to-face meetings, as said. Thank you for your attention.
Yeah, thank you very much to both of you, Sylvia and Uwe, for sharing these very interesting insights into Working Group 4. And with that, we come last but not least to Working Group 5, which is focusing on validation and test. And my first question here goes to Arne Neumann, who is the Working Group 5 Vice Chair. So Arne, 5G-ACIA has just launched its Testbed Program earlier this year. Could you please let us know what this is all about and how many 5G-ACIA testbeds already exist today?
With the Testbed Program, 5G-ACIA encourages and supports its member organizations to practically investigate and prove the 5G technology in industrial applications. This fits very well to the strategic goal of the 5G-ACIA to evaluate and validate 5G key capabilities in realistic scenarios. But what actually is a 5G-ACIA endorsed testbed? It's a group of member organizations of 5G-ACIA, with external partners being welcome, that conducts experiments and measurements. For this reason, they introduce 5G network equipment, either commercial products or prototypes from research and development, into real industrial scenario, fulfilling an industrial use case, for example, collaborative robotics, position detection of goods and machines, or AI-aided manufacturing processes. The result will be shared in a way which allows reproducibility. The first 4 testbeds have been endorsed by 5G-ACIA in January 2021. 2 more testbeds are already very close to the endorsement, and Andreas, I am pretty sure that others will follow soon.
Yeah, thank you very much, Arne, and good to hear that this is taking off now. And as we are getting closer to a more widespread adoption of 5G in the industrial domain, also aspects like the certification of devices and equipment are getting more and more important. And therefore, my last question goes to Lisa Unterberg from IFAC, who is the Working Group 5 chair. Lisa, what special needs do you see here regarding testing, certification, and what is 5G-ACIA doing in order to address these needs?
Yes, indeed. Thanks, Andreas. That's a really valid question. Working Group 5 has recognized that there is a special need for certification of 5G components for industrial purposes, as after all, the end user really needs to know whether the 5G system is able to support his or her application properly. So certification is a key to building trust here. Unluckily, Working Group 5 is not yet able to put a finger on the gap yet, but in order to change that, we recently kicked off a work item that will focus on identifying the gap. And in the first step, we are identifying relevant organizations that are already in place in terms of certifications. And once we've identified the scope and analyzed the scope of these existing organizations, we are looking at that from the industrial users' perspective to identify the gap that there is. And then we will determine in a last step how 5G-ACIA is going to deal with that gap. Yeah, in order to identify the scope of the existing organizations, we're currently happy to have several collaborations in place with organizations like the FNU Alliance, or also that there are some collaborations planned, for example, with the GCF, that Working Group 5 then can rely on when it comes to identify the scope of the certification organizations that are already.
Thank you, Lisa. Thank you, Arne. This was the last working group discussion in this session. We hope you enjoy it, first by listening to the short overview presentation of 5G-ACIA, then by discussing with the 5G-ACIA working group's leaders about various aspects we work on in the Alliance.
So also from my side, thank you very much for joining us today. I hope it was kind of interesting for you, and we would be more than happy to see you again in one of the future events of 5G-ACIA. Thank you very much. Stay healthy, stay safe, and bye for now.